Welcome to day 5. Homework is page 25 to 26. Should also be working on your problem set. Today will be kind of a practice day. We're going to practice each of the things that we have already seen in the unit, especially the congruent triangles implies congruent corresponding parts, because that is a really important one going forward to future units. We're going to pause the video in a second here. You've got some reasons that are started, and then you need to fill in what comes after each of those. So we'll pause the video for 3 minutes for you to get all your stuff out, and you should be trying to do these without looking at your card. Your card should be a last resort. So we'll go ahead and pause for 3 minutes. All right, so the first one, we've got congruent triangles, should imply congruent corresponding parts. Next are two different things that parallel lines imply, and you could have these two in either order: congruent alternate interior angles and congruent corresponding angles. And then we've got we can do the reverse of those because we have the double arrow on our cards. You can do congruent corresponding angles implies parallel lines, and congruent alternate interior angles implies parallel lines. So you can put your warm-up away, heading back over to the homework. So we were given that AB and CD bisect each other. So that segment bisector implies midpoint. This is the only scenario where it will be the midpoint of both things, if it says it bisects each other. So E is the midpoint of both AB and CD. Your midpoint will then imply two congruent segments, and we get two sets of congruent segments since it was the midpoint of both. Do a quick vertical angles implies congruent angles. I numbered them 1 and 2. And now we have two sides and an angle in between, so side angle side. That took care of part A. Part B, we wanted to prove CA and DB were parallel, so get a set of congruent alternate interior angles. So we'll say A congruent to B, and that's by our congruent triangles implies congruent corresponding parts. And then we get that CA and DB are parallel because we had congruent alternate interior angles, which implies parallel lines. For number 2, we had a set of congruent segments. We had a set of congruent angles, the 1 and 2 there. You can do a reflexive, and then that gives you side angle side. We want to get the other set parallel, BC and DA. So we're looking to get what I numbered angles 3 and 4 congruent, because then those would be congruent alternate interior angles. So 3 and 4 are congruent by congruent triangles implies congruent corresponding parts. And then that now gives us congruent alternate interior angles, which implies parallel lines. Number 3, we had CA congruent to CB. Well, with two congruent sides, that gives you an isosceles triangle. Isosceles triangle then also gives us two congruent base angles. I should mention in the givens we had ECB congruent to CAB, and we should be curious, why are they giving us ECB congruent when it's not in our triangle at all? Well, the goal is to eventually get ECB congruent to that angle that I called angle 1, because that would be congruent alternate interior angles. Well, after we get our congruent base angles, notice angle CAB got marked up in two different ways. That allows us to do our transitive property. So now angle 1 is congruent to angle ECB. And then we get congruent alternate interior angles implies parallel lines, which gives us what we wanted to prove. And the fourth one, we had those big sides congruent, BA congruent to BC. And then we had a set of angles BDE and BCA. So those are the ones with the single marks. Well, you can say two congruent sides implies isosceles triangle to get that big triangle ABC isosceles, and then do your isosceles triangle implies two congruent base angles to get angle A congruent to angle BCA. Angle BCA gets marked up twice, which tells us to do transitive property. So now we have angle BDE and angle A congruent, which would be these two angles right here. Well, notice in their intersection, they're both in the top right. So those are congruent corresponding angles that would then imply parallel lines. So if we flip over to page 22, when do we use our congruent triangles implies congruent corresponding parts? And because it starts with congruent triangles implies, that tells us the answer to this. So we would use it after proving triangles congruent. And our reason that we write is the one from our card: congruent triangles implies congruent corresponding parts. So at this point, remember all the ones from our card that we have talked about you want to have memorized. If you don't have them memorized, that should be part of your homework this evening. And we'll go down and start with proof number 1. Go ahead, do your statements, reasons, and givens. So we've got angle 1 congruent to angle 2, so I'm going to mark those in my picture. And we should be curious, why are they giving us those? They're not actually in our triangles. Well, what we want to recognize is there's angles on a line with each of them that are inside our triangles. So I'm going to go ahead and label those angles on a line next to them 3 and 4. And this is what we had on day 2. We're going to have linear pair implies supplementary angles. And we would have angle 1 and angle 3 are supplementary. And in the same step, we have angle 2 and angle 4 are supplementary. And then automatically after that, the next reason is will always be congruent angles implies congruent supplements. Reasons 4 and 5, they always come in a pair right after each other. And so now what this gives us is the angles inside the triangle congruent. So we've got angle 3 congruent to angle 4. And I'll mark those up with 2 arcs and put an A next to that because that now gives us one angle in our triangles. Well, next we've got some perpendicular lines, so we'll go with that sequence. Perpendicular lines implies right angles. S, M, and RT are meeting at M. So I'm going to call those angles 5 and 6 so it's easier to name. So we have angle 5 and angle 6 are right. And then we'll automatically do next our right angles implies congruent angles. And then have the angle 5 is congruent to angle 6. We'll put in our box. And that gave us another angle. Well, angle, angle, angle doesn't work, so we have to do something with a side, and we've got an easy side there with reflexive. So we'll do our reflexive property. Which gives us SM congruent to SM. We'll mark that up in our picture with an X. We have two angles in each triangle marked up. And then that side we just marked up is not between the two angles. Because if it was between the two angles, it would be the side that connects the two angles. So for 9, we will have angle, angle, side congruent to angle, angle, side. When we name our triangles, you name the first thing anything you want. So I'm going to go with RMS. So R was our angle that had two marks in our picture, so that's going to be congruent to T. M was our right angle, so that's M, and then the other one is S. And then the thing that we wanted to prove is that SR is congruent to ST, so we can then do congruent triangles implies congruent corresponding parts. So that's SR congruent to ST. Now, we could have done this proof differently. I purposely had us do it this way just because I wanted us to practice the congruent triangles implies congruent corresponding parts. But in this particular proof, the SR and ST are actually the congruent sides of an isosceles triangle. So we could have veered off after step 5 here. And we could have said two congruent base angles implies isosceles triangle and say that triangle RST is isosceles, and then finish the proof with isosceles triangle implies two congruent sides to get SR congruent to ST. So that actually would have been a little bit shorter in this case, but I purposely steered us this way just so we could practice the congruent triangles implies congruent corresponding parts. If this had been a test question, either way of doing it would have been perfectly fine. All right, moving over to number 2 on the next page, we'll do our statements, reasons, and givens. So we've got ML congruent to AW, and I should note that eventually we want KL congruent to TW. So we're going to want the triangles that are overlapping congruent. So I'm going to redraw those triangles off to the side just so it's easier to mark up, because otherwise it gets pretty tricky to mark some of the things up. So ML congruent to AW, I'm going to mark those with a tick mark here. It's kind of tricky to mark it up in the main picture because of the overlapping. Angle 1 congruent to angle 2, so I'll mark that up here. And then we have KT congruent to MA. Well, what we need to notice is that KT and MA are not in our separately drawn pictures. So I'll mark those up over here. And we need to be curious, why are we given that? How is that going to help us in our triangles? Well, notice that both KT and MA are too short to be sides in our triangles. So when we're too short, we want to do our addition postulate. The thing we're going to add on to KT is TM. The thing we're going to add on to MA is TM. So when you're going to add the exact same thing onto both, we first have to do a reflexive property. And that would give us TM congruent to TM. And now we can do our addition postulate. So we're going to have KT plus TM is congruent to MA plus TM. And then we'll rename right in the same step. That's going to give us KM congruent to AT. And we'll mark KM congruent to AT in our picture off to the side. That now gives us two sets of sides in each triangle, and notice we have the angle that's in between those two sides. So that'll give us side angle side, congruent to side angle side. So name the first triangle anything you want. I'm going to go with triangle KLM, congruent to triangle. K was in between our two marks and no mark side, so that will match with T. L was over on the right there, that's between the one mark and no mark, so that matches with W. And then we have A. And now we want to get a set of sides congruent that are in those triangles, an additional set. So we'll do our congruent triangles, implies congruent corresponding parts. And that'll be KL congruent to TW. All right, we are gonna pause the video for about 12 minutes for you to do numbers 3 and 5. So again, you're going to do numbers 3 and 5 on your own. If you get stuck, feel free to ask people within your group. Try to be doing this without your study card. That would be a last resort to look at that. Okay, but you're not doing 4, you're just doing numbers 3 and 5. And then after 12 minutes, we'll come back together and go over both of those proofs. So go ahead and try that now, numbers 3 and 5. All right, let's go through each of these proofs. So if you had gone head to the homework or something, please flip back to proof number 3 right now. So we had some perpendicular lines. So perpendicular lines implies right angles implies congruent angles. So angle B and angle D are right, and angle B congruent to angle D. Then we have segment bisector. Segment bisector implies midpoint, and then midpoint implies two congruent segments. Because BD came after the word bisects, C is only the midpoint of BD, and that gives us BC congruent to CD. Then you have some vertical angles, implies congruent angles. I call those angles 1 and 2 in our picture when I said they were congruent. Two sets of angles with a side in between, so we should have angle side angle congruent to angle side angle. In your name of your triangles, the A and the E should be in the same spot, the B and the D should be in the same spot, and the two C's should be in the same spot. And then congruent triangles implies congruent corresponding parts for what we wanted to prove, AB congruent to ED. Moving over to number 5. Our givens gave us a side, then we have angle bisector implies two congruent angles. When you trace your angle PMR, M is the middle letter, so M is where all the action is happening. So notice I labeled those 1 and 2, so those are the angles we get congruent. Then you've got a reflexive property, MQ congruent to MQ. Triangles are then congruent by side, angle, side. I named my first triangle PMQ, so wherever you have P, that should match with the R. Wherever you have M should match with the other M, and Q matches with Q. And then finish it off with a congruent triangles implies congruent corresponding parts to get what we wanted to prove. Any time remaining in the period, you can be working on your homework or your problem set. Have a great rest of your